All right, so sample problem 3-1. How many protons, electrons, and neutrons are there in an atom of chlorine 37? So we actually have to have three answers here. Number of protons, number of electrons, and number of neutrons, specifically in the type of chlorine that has a mass number of 37. Again, as you work through these types of problems, you want to take stock of what you actually know. That functionally, this means look at the question. What does the question give you? So again, our given, we have the name and the mass number, right? It's chlorine. So we can go to the periodic table, which for you, the periodic table that you have access to right now is at the end of your book, right? The very, very back cover. So you can, and then if you're actually in a room, you can simply look up here, or because you have your Chromebooks, or if you just happen to be at home on a laptop, you can simply Google search periodic table of elements, click on the images tab, and you're going to get tons of periodic tables in an instant. So I'm never asking you to memorize information on the periodic table. Never. I always want you to have access to the periodic table. And that's a big distinction. So we know name, we know mass number. What don't we know? Again, numbers of protons, numbers of electrons, numbers of neutrons. Now, what we need to know here are some definitions. We need to know the definition of atomic number. Atomic number is the number of protons in the nucleus. You can see there's an equal sign right here for number of protons. Now you can also see that number of protons equals number of electrons, and that might be a little confusing because you're thinking, well, I just learned that the atomic number is the number of protons in the nucleus, and it didn't say anything about electrons. Why is my textbook telling me that these things are equal now? Well, right now, you don't know anything about ions yet, about things that have a charge overall. Right now, in your development, you think that all atoms are neutral, such that however many protons there are in an atom, there have to be the exact same number of electrons. Now that'll change. We'll add to what you know later on, but right now, that's what you guys know. And so because of that, we have to assume that the number of protons is equal to the number of electrons. Again, that won't always be the case because we're going to introduce the ion pretty soon, but we don't know that now. So for right now, we can assume that the number of protons is equal to the number of electrons. Other major concept we need to know about is the mass number. What is the mass number? It's the number of neutrons, okay? Neutrons plus the number of protons. And notice we're not saying anything about the electrons here at all. So mass number only refers to nucleons. Remember, nucleon is that special word that refers to the subatomic particles that are in the nucleus. So here's what we know. This is how we're going to use this information. Let's clean up the board. I'm going to have to scroll the PDF down. All right, so we know that the mass number of chlorine 37 is 37. Okay, that's why it's so important that we actually give you that proper name, that hyphenated isotope name. Consulting the periodic table, meaning looking it up. Okay, this isn't something that you're supposed to memorize. Consulting the periodic table reveals that chlorine's atomic number is 17. So we actually have mass number and atomic number. We get one of them from the periodic table and the other from the question. These aren't things that you have to just have off the top of your head. So now that we have these numbers, the number of neutrons can be found by subtracting the atomic number from the mass number. Okay, right? So mass number of chlorine 37, subtract the atomic number of chlorine. Right? That's our basic setup. So based on what we know, mass number minus atomic number is 37 minus 17. Now remember our definitions. Mass number is the number of protons and neutrons in the nucleus. Atomic number is just the number of protons. So in order to figure out the number of neutrons, we have to get rid of the number of protons. That's why we subtract. And we end up with, through simple arithmetic, 20 neutrons. All right, so we got the hardest part of the problem. So an atom of chlorine 37 contains 17 electrons, 17 protons, and we know that because, again, consulting the periodic table, we see that the atomic number of chlorine is 17. And right now we're assuming that all atoms that we're working with are electrically neutral. And so the number of protons and electrons has to be the same so that they'll cancel each other out. And simply subtracting the two values gives me the number of neutrons at 20. Again, in conclusion, the number of protons in a neutral atom equals the number of electrons. Again, in a neutral atom, this is the key here, in a neutral atom, we won't always be talking about neutral atoms, but right now we are. And the sum of the protons and neutrons equals the given mass number. And again, given because the question actually gave it to you.